Um, so today we're doing chapter 2. This is probably the easiest thing we do in second semester because it's basically like slopes and equations for lines and like solving systems of equations and yeah, I understand. Chapter 12 was hard. This is much easier. As I mentioned before, I kind of think that what we did in chapter 12 was probably the hardest thing we do in the course. I think it's kind of the hardest thing in the course. So we're just going to start with some basic vocab to recap. So a solution, or sometimes we'll use the term root, it's just a value that's a value for a variable that satisfies an equation. A solution set then is the set of all solutions to an equation. And an identity is an equation that is true for all possible values of a variable. So a classic identity that we're all familiar with from last year. Cosine squared plus sine squared is equal to 1, right? Like any values of theta there, still it's always equal to 1, right? So let's say that we have like example for an equation, say we have 2x plus 4 is equal to 8. Ooh, scary. The solution there, we would say x equals 2. So the solution set would just be the set containing one value, the only solution, 2. So far, so good. Pretty basic. So a formula is just a type of equation, but it usually contains more than one variable. And oftentimes contains like parameters or constants. So example, like the area of a circle is pi r squared. Area and radius are both variables. Pi is a constant or a parameter. Everybody feel okay there? So just a little algebra review. So let's say we want to solve a formula for a given value. So if I have a squared plus b squared equals c squared, and I want to solve that for b, what would I do first? Good, we'll subtract a squared from both sides. Then what? Square root both sides. Okay. Anything else? Am I missing anything? Not quite. There is something missing though. So a square root doesn't distribute, so you can't cancel the squares with the square root here because it's the minus sign in between them. Yes, there should be a plus or minus out front. Why is that? Yeah. Yeah, whenever you do a square root to both sides of an equation, it generates a plus or minus. Easy to forget that. So for our second equation here, we're looking to solve for L. What should I do first in order to solve for L? What's up? Oh, okay. Yeah, divide by 2 pi. Okay. Then what? Square both sides to cancel the square root. That's good. So remember, when we square both sides, I have to square like that entire thing. And then multiply by g. And if you wanted to, you can square that fraction. How do I square a fraction? You just square the numerator and square the denominator, right? So I'd have gt squared over 4 pi squared equal to L. So really either one of those would be fine, but it's okay. And then our last example here was I equals NR over cap R plus little r. And here we're looking to solve for capital R. What's different about this formula than any of the previous ones? Well, sure, but there's something else here that I think is more fundamental that causes a little bit of problem here. Yeah, the variable's in more than one location, right? What we're trying to solve for is in more than one location. So at some point along the way, we're going to have to combine some like terms to get that capital R all by itself. Uh-oh. Okay. What should we do first here? Yes, agreed. So basically to clear the fraction, right? So we're going to have oh my God. This is how the day's going to go, isn't it, everybody? Okay. Okay. So we have that, right? Next, what should we do? I wouldn't do that yet because I have r's on both sides of my equation, right? Before I start dividing, I'd want to get the r's in the same side. Yeah, so let's distribute that I through. And now let's subtract so that the r's are on one side. Does that feel okay? So now I have the r's on one side. How do I get the r's in one spot, though? I have two r's right now. I have r in two locations. How do I get in one location? Yeah, I just do a greatest common factor. So I just factor that capital R off. Now it's gone from one location to from two locations to one location. And now I can just divide by the quantity n minus I, and we're good. Feel okay? Again, just kind of rehashing some basic algebra solving skills. The case where you have variables in two different locations is the trickiest one. All right. So next we're going to talk specifically about linear equations. Fundamental to all linear equations is they contain a slope. Our formula for our slope is commonly abbreviated with the letter m. And the formula for slope is your vertical change over your horizontal change, or for points x1, y1, x2, y2, y2 minus y1 over x2 minus x1. Everybody remember slope from middle school and on? So a piece of vocabulary here, the IB is going to ask you to write equations for lines in different forms, and they use a slightly different vocabulary as an international entity than we do in America. So when we talk about general form, that's commonly called standard form over in our classrooms, but there's two different representations. The catch here is, though, is that A, B, and C have to be integers. So that's usually the trickiest one to get because it involves like clearing potential fractions out of there. So just keep that in mind. The second is gradient intercept. That's what we commonly call slope-intercept form, where m is the slope and 0, c is the y-intercept. But they're using a c instead of a b. Whoop-diddy-do, it's still y equals mx plus b. It just got a different name to it. And then there's point gradient form. That's commonly called point slope form in our classrooms. So if you have a point x1, y1 and a slope m, then our equation is y minus y1 equals m times x minus x1. And then here we've listed also the two special cases if I have a horizontal line or a vertical line. Remind me what the slope of a horizontal line is again? 0. So it's essentially still that gradient intercept form. We've just plugged in 0 for m and multiplied it by x and then added 0 to c to just get c, right? The one that usually causes confusion is the vertical line form. What's the slope for a vertical line? Undefined. So what do I do? How do I get this c? It's going to be any x coordinate from a point on the line, right? Notice this one starts x equals c. So you're going to choose any x coordinate from the line, and that'll give me my equation for the vertical line. That one usually trips students up because they get the undefined slope and they call it 0 and go about their way because they forget that 0 over number is 0, number over 0, undefined. So if we want to, without using a calculator, sketch the line for each linear equation. So if I'm going to sketch a line, how many points do I need on that line? 2. Great. What for A, What 2 points do you want to find? Okay, so you need to find an x and a y, sure. So can somebody tell me an xy that satisfies this equation? I tend to find when I have an equation in general form like this, that the intercepts, the x and y intercepts, are the easiest points to find. So if I pick x to be 0, what does y need to be? Close. Oh yeah, I'm sorry, 2 is correct. Okay, and then if I pick y to be 0, what does x need to be? It's a fraction, 6/5, right? Because 5 times 6/5 is just 6. So then we can just plot those guys and go about our business, right? Now for B, what do we notice here? What's different from B? There's only one variable. What is the variable? Y. Okay, so guess what that means for x? Can be anything we want it to be. It's a free variable. So let's just pick x to be 0. What does y have to be? 4. Let's pick another x. Maybe this time we'll pick it to be 1. What does y have to be? Still 4, right? You might have also noticed this is a horizontal line. So just going to go, through the point 0, 4. If I look at C, what do I notice? There's no y, right? We have only an x. So the y is our free variable. What does the x have to be in any case? -3, right? And then y could be whatever we want. So there you go. Everybody feel okay? Kind of remember doing this stuff? It might have been a while, but it's hopefully a welcome change from finding probabilities of what we were just doing. So, all right. So another situation, let's go the other direction. Here you're given information about the line and asked to come up with the equation. So it says, find the equation of the line that passes through the point 3, 31, has a gradient of 12, and they ask it to write this in a gradient intercept form. So that's that form. So we need to figure out M and C then, right? Okay, can somebody tell me one of the two right away? M is 12. How'd you get that? It literally says it in the problem. So we can then say, okay, y equals 12x plus c. How are we going to find that c then? What haven't we used yet that was given to us in the problem? The point. What should I do with that point? Plug it in. Great. Where does it go? The x and y, right? The point is in xy, so it gets plugged into x and y. So then I can solve for c, and now I just rewrite there's my answer. Does that feel okay? Hopefully this feels pretty familiar. The next says find the linear equation in C and F, knowing when C equals 10, F equals 50, and when C equals 100, F equals 12. Solve for F in terms of C. Oh, Mr. Kulik, this seems weird. I don't like the way this is worded. Go away. Well, what is this saying? When C is 10, F is 50. It's really just the point 10 comma 50. So what's the other point that's given? 100 and 212. Okay. So what do I need to do then? Find the slope. Great. So 212 minus 50 over 100 minus 10 is going to be 162 over 90. And I don't feel like reducing it by hand, and you'll never have to do anything without a calculator, so let's take advantage of that. So the easiest way to reduce a fraction by hand with your calculator is I'm just going to type in 162 over 90 and then press math frac. And there's my reduced fraction. Everybody's okay? So that's 9/5. Okay. And then it says I want an equation of F in terms of C. So if this is like X and Y or C and F, you're welcome. What kind of an equation do I really want to write here? Yeah, very good. Except we'll call it F equals MC plus little c. Everybody's good so far? So again, how do I find that little c? Plug in a point. Which point do I use? Does it matter? No. Which one should I pick? Which one seems easier to deal with? The one with the smaller numbers, please. And thank you. Who knew the answer when they saw what the points were? No. Look at the numbers on the points. Look at the numbers for the points. Does that look familiar? 50 minus 18? 100 and 212. That's the boiling point of water in Celsius and the boiling point of water in Fahrenheit. So as soon as I saw that, I knew. I was like, oh, this is just going to be the equation to convert Celsius to, or Fahrenheit to Celsius, or Celsius to Fahrenheit. That I knew that as soon. I knew what the answer was going to be. You knew that. No? Okay. Well, you could have. 100 degrees or 100 degrees Celsius is 212 degrees Fahrenheit. That's the boiling point of water in either system.
So when it's asking us to solve like F in terms of C, that's always going to be like y equals mx.
That's going to be F by itself, and then C is on the other side.
And then we put it into y equals.
So that's going to be a y equals mx plus b kind of problem, where F is the y and C is the x.
Yeah.
Okay. All right.
So mad. I was so mad. Don't do any torn.
All right. Shh. Parallel and perpendicular lines. How do I tell if two lines are parallel or perpendicular? Okay. Great. So the two slopes are negative reciprocals. Or what kind of lines don't have any slope at all? Vertical. What kind of lines are, so vertical lines don't have any slope, so what's going to be perpendicular to a vertical line? There you go. Okay, we hope for those situations because they're super easy, right? Everybody's okay? Horizontal lines are fine because they just have slope 0, so the explanation holds. All right, so we have the line y equals 3/5 x plus 2. What is its slope and y-intercept? And its y-intercept is, well, we'd write it as a point, 0, 2. Find the equation of the line that passes through the point 1, 5 and is parallel to that line. Bless you. So since it's parallel, I know its slope is 3/5, right? So I just do my y equals mx plus b, or c, I guess. So that's going to be 22/5 when I subtract that over. Yes.
So that one's got to be 5 and that y. First line.
Because I do x, y, right? Yep. So far, so good? For part C, it says, find the equation of line that passes through the point 1, 5 and is perpendicular to the given line. What's my slope now got to be? Negative 5/3, right? The negative reciprocal. Everybody's cool? So C is going to be 20/3. Is this okay? You guys remember doing this from pre-algebra, algebra, geometry? I think you do this at least 3 classes. If it's not, it needs to be, okay? It needs to get okay with it, okay? Next example, it says line L is given by the equation 3y plus 2x equals 9. Notice that's the general form equation for a line. And point P as the coordinates 6, -5. Explain why point P is not on the line L. What's going to be the easiest way to show that this point is not on L? Just plug it in and show that it doesn't give us 9. Exactly right. Everybody's okay? So I just plugged the point in and showed that it wasn't equal to what it's supposed to. Good enough. Next it says find the gradient of line L. Very good. How'd you get that, Joey? Good. So Joey just put this into slope-intercept form. And then read the slope off. That's probably the easiest way to do it. It's the way I would have done it. It says in part C, part I, it says write down the gradient of the line perpendicular to L. 3/2 is correct. I negate it, so the negative goes away, and then I flip it. And then part 2 says find the equation of the line perpendicular to L and passing through that point P. Everybody happy doing this kind of stuff? Was I lying when I said this is pretty easy? No, it should be okay. All right. The last thing we'll talk about in chapter 3 is solving. Oh, no, I lied. There's one more thing after this. Second to last thing we'll talk about is solving systems of linear equations again. So there are 4 techniques that you guys have seen before. So you can use it. You can solve these by graphing. It says with technology, so you'd be typing in your calculator and just kind of looking at the picture. Substitution, elimination, and the 4th is technology without graphing. So that would be like using a matrix. There are 3 possible solution types that we can get when solving a system of linear equations. We can get exactly one solution, i.e. the lines intersect at exactly one point. We can get infinitely many solutions where the 2 lines coincide, i.e. they overlap and intersect at every point on the line. Or they can have, the 2 lines can be parallel. There can be no solution where the lines never intersect. And I just drew in a picture here of one solution, infinitely many, and then no solutions. I'm sure that you pictured this in your head quite easily, but I wrote them down anyway. All right, use the graphical features on your graphic display calculator to solve each system of linear equations. So in order for me to do this graphically on my calculator, how does what type of equation do I have to have? Has to start y equals, right? So for the first one, I would say y equals negative 2/3 plus x plus 2. And the second equation would be y equals 2x plus 10. Is everybody okay with what I did there? I just got the y's by themselves. I didn't show the algebra. Are you okay with me not showing the algebra? I hope so. All right. So into my calculator we go. If you have your calculator with you and you wish to follow along, because you're like, ooh, I don't really remember how to do this, that's great. I encourage you to do so. So I'm just going to go ahead and type in the 2 equations as they appear on my sheet of paper into my calculator. Notice that the y equals already supplied for me on the calculator. And then to graph this, I'm going to do zoom standard. So I'm just going to press zoom standard. That's just going to take me back to the negative or the regular negative 10 to 10 window that typically when people design textbooks, they get the answers to go on a window like that. But what I'm about to show you will not work if you can't see the intersection, right? So to find that intersection, I'm going to press second and then the trace button. I'll select the intersect command. And here's the nice deal. How many lines did we graph? Just 2. How many times are they going to intersect? Once. So all these parameters that it's asking me for don't really matter. I'm just going to press enter 3 times and it'll spit out my answer here at the bottom, -3, 4. So far so good. Let's do the next one. So I'm going to have 7/5 x minus 4 and then -3x plus 2. So again, just do it the exact same way. And since I've already set my window, I'm just going to hit graph. There's my intersection, second trace, intersect command, enter, enter, enter. And I get this guy. Now, how should I round this? Look at the bottom. I got a kooky decimal. What should I do? 3 sig figs. So the first number should be 1.36, and the second one would be -2.9 or 0.9. Incidentally, that's like 15 over 11 and -23 over 11. But you wouldn't have gotten that unless you solved it algebraically, right? You couldn't have done it on your calculator that way. All right, let's solve this one via elimination. What is the goal in elimination? Yeah, I want to multiply the equations by some number, possibly different numbers, so that when I add them together, either both x's or both y's cancel, right? So which one do we want to cancel here, x or y, or does it not matter? Okay, it doesn't really matter, but let's do y's. What do I need to multiply the first equation by to cancel the y's? 4. And the second equation? 3. So I'd have 15x plus 12y equals 36. And then 6x minus 12y equals 42. And then we add down. Those cancel out, so I have 21x equals 78, right? Yes, sir.
Can you just put this in like a matrix?
Absolutely, you can, but the direction said to use elimination, so I'm following the directions. But yes,
I was wondering how do you
we'll do that.
Okay.
Yep, we will do that. Oh my gosh, guys. 4 times 5, is that 15? How come nobody yelled at me? Shame on you guys all. You're just like saying, whatever you say, Mr. Kulik. You knew the boiling point of water. My mind is blown. So I get x equals 3 there. What do I do now? Where? Either equation, right? I'm going to do equation 2 because the numbers looked a little smaller. So I could say then 3 - 2 is the point. Yeah, so far so good. Real quick as to Joey's question, how do I use a matrix to solve this thing? So what I'd want to do is first I want to make sure my equation is arranged so like the x's are all in a row, the y's are all in a row, the equal signs are all in a row, and the answer's all in a row. Has to be formatted that way, which this one already is, so I don't have to do anything. And I'll press second and the matrix button. I'll go over to the edit tab. And I need a 2x3 matrix. I have 2 rows, 1 for each equation, and I need 3 columns, 1 for the x's, 1 for the y, and 1 for the solution. And then I'll just type in the coefficients as they appear. So 5, 3, 9, and then 2, -4, and 14. I'll exit out to the main screen. Now I'll go back into the matrix menu. Go to the Math tab, scroll all the way to the bottom and retrieve the RREF command. And I'll do that on my matrix A that I just wrote. It outputs you, the first row is at 1x plus 0y equals 3, or just x equals 3. And then 0x plus 1y equals -2, or just y equals -2. Nifty little thing to have at your disposal, because the calculator rarely makes arithmetic mistakes.
So it doesn't have to be in y equals x.
It should not. In fact, it cannot be. It has to be in like x plus y equals constant. Yeah, it's got to be RR. It's like the stuttering pirate. RR. No, nobody thought that was. You're not even listening to me anymore. All right. How do I do substitution if it asks me to do that? Great. Perfect. Which variable would you want to isolate here? Yeah, the y in the first equation, right? So 3x plus 9 should equal y. Everybody's cool there? So when I plug that into the second equation, now I will say, as a point of caution, you have to be careful. You can't substitute back into the equation that you used to find the value to substitute. Has to be into the other equation. If you do, everything will cancel out and it just looks like it's infinitely many solutions. It's
You plug it into 3x minus y.
no! Not if you expect to get an answer. All you're going to get is an identity. If you plug the equation back into itself, everything will just cancel out and you'll get left with 0 equals 0 and think, oh, infinitely many solutions. You're wrong! So just be careful on that. So there's that. And then what do I do once I have the x? Great. Where would be the best place to plug it into? I plug it in here because the y is already by itself. Joey, what you said would not be wrong, but like, this is way easier, right?
So we can plug it into the simplified, or like the more
Yes.
change.
Yes. Yes. An answer you could plug in anywhere, right? An equation you have to plug into the other one. You know what I'm saying, Victor or Grace?
Oh, I thought you meant we couldn't plug in the x into the first equation.
No, you can do that. You can't plug this into here because that's where it came from. That's what I'm saying. That's a no-no. All right. What if we give you a story problem? Oh, no! When flying in still air, i.e. no head or tailwind, with its propellers rotating at a particular rate, a small airplane has a speed of s kilometers per hour. With the propeller rotating at the same rate, the airplane flies 473 kilometers in 2 hours. as it flies against a headwind, and 887 kilometers in 3 hours with the same wind as a tailwind. Find S and find the speed of the wind. So S is in kilometers per hour, right? What should S be multiplying by? If your variable's a rate, the number that it should be multiplying should have the unit in the denominator of your rate. So if S is in kilometers per hour, I need to be multiplying S by hours. So in the first equation, I'll have 2 times S. In the second equation, I'll have 3 times S. Everybody's okay? Okay. And then we're flying against a headwind, right? We have some wind speed. So W is going to be that wind speed, also in kilometers per hour. So if you're flying against a headwind, is that going to speed us up or slow us down? So should I be adding or subtracting? Subtract. And your wind speed is in kilometers per hour, so what should it be multiplied by? Hours. And what should this equal? Some unit in kilometers, right? Because when I multiply kilometers per hour by hours, I get kilometers. Yes? Now the same situation, but this time we have a tailwind, but it's the same wind, right? So what should I be doing here? Should it be speeding me up or slowing me down? Speeding me up. So what should I be doing? Adding or subtracting? And how far did I go? 887. Yes, sir. So in the question, it asks, find S and the speed of the wind. So I defined W as the speed of the wind. Because it's blowing the whole trip, right? The airplane flies 437 in 2 hours as it flies against the headwind. So the airplane's propellers are going for 2 hours, but the headwind's blowing against them for 2 hours. Alternatively, if it made more sense to you, you could think about it as 2 times S minus W and like 3 times S plus W. Right? You could think about it that way, where the wind speed is just affecting the propeller rather than as a distance, but it doesn't matter. Either way, you're going to get to the same spot. Does that feel okay? Yeah. Okay. Solve this. I'm going to use a matrix because if it doesn't tell me what to do, that's my first option because, like, it's kind of idiot proof. And the numbers here are, like, not super duper convenient. So that's what I got here. I'm going to, I guess we'll just round this to 3 sig figs, I guess. If I round this to 3 sig figs, what's my answer for S? It's 266. What's my answer for W? 29.6. 3 sig figs. I'm going to tell you right now on this test, I'm going to grade you down if you're not doing your sig figs right. Oh no! Okay. So far, so good. Next up, we're going to talk about relations and functions. So when we talk about a relation, this is just a pairing between two sets. A mapping diagram is a way to represent a relation. So usually when we draw a mapping diagram, we just have like we do something like this. You guys remember mapping diagrams, what those looked like? Yeah. Okay. So the input is just like, kind of like the domain. The output is like the range. What's the difference between a function and a relation? Every input has exactly one output. Okay, so let's take a look at some examples. We'll decide if they are functions or not, and then we'll state the domain and range, i.e. the set of inputs and outputs. So this first one, is this a function?
Yes.
Yes, good. What's its domain? Elephant, goat, horse, rabbit, tiger. What's its range? 10, 25, 50. Everybody's okay with that? Here, since there's finitely many of these inputs and outputs, I'm just going to use the squiggly set notation rather than describing it as like an interval or something. How about this one? Is this a function? No. Why not? And so does 5, right? Those are both problems. What's the domain? 1, 2, 5. What's the range? 0, 1, 2, 3, 4. How about this guy? Is this a function?
Is it fails vertically? No, it passes. But it fails. What do you mean horizontal?
Is it a function?
Yes.
Yes. Okay. What's its domain? And what's its range? There you go. The domain is all real numbers. What is the range? Okay. What are the symbols at the ends of this? Bracket, and then very good. Why is there a bracket here? Because 1 is a member of my range, right? I can look right here and see, oh yes, 1 is absolutely a point on this function. Everybody remember doing this, Grace?
When you do horizontal.
It's coming. Sit tight. What about this one? Is this a function? No. Why not? Fails the vertical line test, right? Great. What's the domain? Nope. Oh, okay, positive infinity, but you start at the small to big always. Not 0. 1 to positive infinity. What are my symbols? What's my range? Nope. 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 Yes. There's arrows at the end, right? That line is getting taller the whole way, right? Just like this line is getting smaller the whole way. It's covering the entire y-axis. Cool? Absolutely. All right. Here it says to express the volume of a cube as a function of edge length of the cube. So here we're just going to write function notation equations. So volume as a function of edge length. So I'll write V of E equals. Everybody's okay with that? And then how do I find the volume of a cube? Length times width times height. In this case, that's going to be E times E times E, or E cubed. For volume, I mean, if you did like the volume of a cylinder is like pi r squared h. All right, so part B says find the total surface area of the cube as a function of edge length. So I'll say SA of E just 6e squared. How much area is one face? E squared. How many faces do we have? 6. So 6e squared. I think you said 6e times e squared.
Oh, okay.
That's okay. Maybe I misheard. But you had absolutely the right idea. The 6 was the hard part to come up with, but it's like, how many sides is on a dice? What shape is a dice? Dur, dur, dur. All right. Let's do some domains. So for the first function, it's listed as a set of ordered pairs. What's the domain? That's correct. What's the range?
0, 3, 4.
Excellent. I love that you didn't include the 0 twice. Sets have only list the number once. So even if a number appears in a domain or range more than one time, you do not list it more than once. Do they need to be in ascending order? No. Sets are unordered, so the order does not matter. You could have started with from the right-hand side and gone to left-hand side, or you could have just pulled them out randomly. It doesn't matter. Okay. B, it says the volume of a sphere, V is 4/3 pi r cubed. So the domain is referencing which variable, r or v? Nope. R, because it should be the independent variable, right? Volume depends on radius. So what are the acceptable values for the radius of a sphere? Can it be negative? Does that make any sense to have a negative radius for a sphere? Okay. No. Can it be 0? No. I would say no is fine. Can it be any positive number? Okay, so what should my domain be? 0 to positive infinity, but not including 0. So I use the parenthesis. The range is representing then volume. What are acceptable volumes for a sphere? Yes. Can't be negative, can't be 0. Any positive output is okay, though. For C, domain and range, what am I going to do here? Oh, I guess it doesn't ask for a range here. Great. Why can't x be 3? Great. So we would say then negative infinity to 3 union 3 to positive infinity. But anything else is fine, right? It didn't actually ask us for the range, so I'm not going to do it here because it's kind of an incredible hassle to do it algebraically. What about for the part D? Sure it can. The square root of 0 is just 0. Great. So x must be less than or equal to 3, correct? That's what we're saying? If you're bigger than 3, you're square rooting a negative, and that's no bueno. So what do we write then? Negative infinity to 3 with a bracket, right? That's everything less than or equal to 3. That feel okay? What if we want to do domain and range for this guy? Well, the domain should be fairly easy, right? It's the same idea as the last one that we just did. So it should be greater than or equal to 2. Very good. So that should be what interval? But with the bracket, right? Because it's or equal to. What's the range going to be? Okay, what's the smallest thing that can come out of that square root? 0. So what's the smallest y value got to be? Plus 1, right? So 1. And those things coming out of the square root are always going to be non-negative, right? So is the 1 going to be getting bigger or smaller? Bigger. So where are we going? Positive infinity or negative infinity? That's it. Just think about it that way. Feel okay? All right. How about this one? Can somebody tell me the domain? Negative infinity to 2 union 2 to positive infinity, right? Everything except for 2. Everybody's okay? Because what's the only problem here? 0 denominator, right? There's only one number that's causing that. Now, what's the range going to be? It's not negative 1/2. So on that on the one, no, because it doesn't include 2, right? Because 2 makes a 0 denominator. So let's think about it this way then. You have a fraction, it's 1 over something, right? Okay, can I pick something for that fraction to be like a whole number? Yeah, right. I just pick the composite unit fraction and it'll give me the whole number, right? So any whole number I can make. Except for 0, right? If I have a 1 in the numerator, how do I make that fraction into 0? I can't. That's the hole in my range.
So is that always going to be the range? Or just a fraction?
Depends if there's anything added afterwards, right? So like, as an aside, so this was what we called a simple rational function back in Algebra 2. So this has a vertical asymptote at x equals h and a horizontal asymptote at y equals k. That k is going to be the hole in the range. That h would be the hole in the domain. So that's an easier way of doing it. It's just recognizing like, oh, I know what this thing is. That's a simple rational function. All I need is the h and k, and I can write the domain and range instantly. That's the way I think about it. Okay. Well, what about this crazy looking thing? Oh no! What are we doing with this? What's the problem here? There's two problems for the domain, right? The square root and the denominator, right? So I know the denominator can't equal 0, so what value can x not have? Or, everybody's okay with why it can't equal 3 or -3. That'll give me 9 minus 9, which is a 0 denominator, no bueno. Okay? What about the square root? What values of x are going to give me a negative under the square root? Or less than -3, right? Those are my sad numbers. What's left? The stuff in between -3 and +3. That's my domain. Is everybody okay with that? Okay. So let's think about it this way. What's the smallest number that can come out of, or what's the biggest number that can come out of the square root? Well, square root of 9, so 3, right? So I know 1/3 can, that the biggest number out of the square root is 1/3, which means that the smallest number for f of x, the biggest number to come out of the square root is 3, so the smallest number for f of x would be 1/3, right? Because the biggest denominator is going to be the smallest number. Everybody agree with that? So my range I know is going to start at 1/3, and that's going to get a bracket because obviously if I put 0 in for x, I can get that. And then what are we going to head towards?
0 or 1.
Well, the closer I get to 3, what are we getting? What's happening to my denominator? No, the closer I'm getting to 3, the closer the denominator is getting to 0, right? So I can get a denominator of like 0.000001, which is going to make an enormous number. 1 over that is like 1,000,000. So positive infinity. Okay. Thank you. If you have your activity and you want to turn that in, I'll take those. Thank you, sir. And we'll finish up the rest of this chapter next time. Thank you. Yeah, I'll put the problem set on the assignment center on My Notre Dame. I'll make an assignment for it. But you could start working on that already.